The focus of this lesson is on solving exponential inequalities. Part of the solving process of an exponential inequality is you will be applying the natural log both sides of the inequality at some point, which doesn't change the direction of the inequality symbol. However, sometimes you have to divide that natural log expression off from both sides of the inequality. Well, depending on whether that natural log expression is positive or negative, your symbol of your inequality could actually change direction. So if the expression is negative overall, and whenever you divide by a negative on both sides of an inequality, then the symbol would have to switch. So that's a caution to you to pay attention for that step in the solving process so that your solutions come out correct. So let's go ahead and take a look at an example. So we have 5 times 3/10 to the x plus 1 is less than or equal to 11. So we want to go ahead and isolate that exponential expression just like we would with the equations. So we're going to subtract 1 from both sides, and we're left with 5 times 3/10 to the x is less than or equal to 10. Divide by 5 on both sides. That gives you 3/10 to the x is less than or equal to 2. Now to solve, because these are, I can't write in terms of the same base, I need to apply my natural log to both sides. So I'm going to apply the natural log to 3/10 raised to the x, and then apply it to the 2 on the right hand side, which allows me to use my power rule, which makes this x times the natural log of 3/10 is less than or equal to natural log of 2. So the next step is to divide off the natural log of 3/10. But the natural log of 3/10 is negative. If you put that in your calculator, you'll see that the value is negative. Well, if that's the case, when I divide it off from both sides, it'll leave x on the left-hand side, and then it'll leave natural log of 2 divided by the natural log of 3/10 on the right-hand side. But then that inequality symbol does have to change direction, so there's greater than or equal to. And so then you would go ahead and take the natural log of 2 divided by the natural log of 3/10 in your calculator, and you would see that that's approximately negative 58 hundredths. So x is greater than or equal to negative 58 hundredths. So if you write that in interval notation, you'd use a bracket since you could be equal, and then negative 58 hundredths, and then anything bigger, so to infinity, and then use a parenthesis to close that off, and then that would represent your solution set. Let's go ahead and take a look at our next example. So we need to go ahead and isolate our exponential expression 1.2 to the x. So we're going to start off by subtracting 11 from both sides. And that gives us negative 3 times 1.2 to the x power is greater than or equal to a negative 3. Then we'll divide by negative 3 on both sides, which gives us 1.2 to the x. And then on the right hand side, negative 3 divided by negative 3 is a positive 1. But because you're dividing off a negative, that inequality symbol does have to switch directions. So then we would apply the natural log to both sides, which does not change the inequality symbol's direction. But then what that does allow us to do is to use our power rule, which pulls that x down as a multiplier times that natural log of 1.2. And that's less than or equal to natural log of 1. And then we would divide off the natural log of 1.2, but we want to be mindful, is that natural log expression positive or negative? But the natural log of 1.2 is in fact positive, so you don't have to worry about the inequality symbol changing directions. So if I divide by natural log of 1.2 on both sides, I maintain that I'm less than or equal to, and then it becomes natural log of 1 divided by that natural log of 1.2, which is a 0 since the natural log of 1 is 0.